Construction requirements for field instrumentation. All working practices shall be in accordance with company regulations regarding safety to work. All work shall be executed in strict compliance with approved drawings and specifications. Any proposed deviation from the approved drawings or specifications shall be submitted in writing to the company. Written approval from the company is required before proceeding with design changes. The cost of any rework due to work undertaken from non-approved deviations shall be the contractor's sole responsibility. Any areas of the drawings or specifications that conflict or do not meet applicable codes or safe and acceptable installation practices shall be submitted in writing to the company. The conflicts or exceptions shall be brought to the company's attention immediately upon discovery of any problem. Locations of the instrument stands, marshalling boxes, etc., shown on layout drawings are approximate. Contractor shall be responsible for final location of the instruments, considering all relevant installation requirements of this specification. The overall availability and reliability of the instrument installation shall be demonstrated by the contractor. Unless otherwise stated, the construction design life shall be 30 years, with an uninterrupted period of operation of 3 years. Plant hazardous area classification will be carried out based on the Institute of Petroleum Model of Safe Practice, Part 15, Area Classification Code for Installations Handling Flammable Fluids, 2002 edition. Instrument installation shall be suitable for the hazardous area specified. The equipment instruments for installation in classified and/or corrosive locations shall be suitable for the hazard classification of the area and be resistant to the corrosive environment specified. Bulk materials, such as gaskets and sealants, shall be free from asbestos, ceramic fiber, chlorofluorocarbons, polychlorobiphenyls, PCB and their isomers, radioactive materials, mercury. Dangerous goods shall be labeled and identified. All hazardous materials shall be supplied with a Material Safety Data Sheet, MSDS. Contractor shall, prior to commencement of work, check and confirm that the quantities of free-issue materials as specified in the Bill of Materials are sufficient to complete the works in accordance with the particular specification. Supply of other materials required to complete the installation in accordance with this specification is the responsibility of the contractor. Materials supplied by the contractor shall include but not be limited to instrument stands, marshalling box stands, test equipment, material necessary for the fabrication of supporting brackets, nuts, bolts, washers, labels, cable identification ferrules and tags, and crimps. A list of construction materials to be supplied by the contractor shall be submitted by the contractor to the company for approval prior to placement of any orders. Material quantities shall be determined from the instrument installation contract drawings and schedules. All materials shall be new and unused, free of defects, and shall be supplied with relevant certification and documentation. If the contractor is responsible for the design or procurement of tagged instrument equipment, the contractor shall conform to the equipment specification for the particular instrumentation type. The contractor shall use only non-asbestos products. All materials provided by the contractor shall conform to this specification. The manufacturer and type of installation materials shall be standardized to the maximum extent possible. The installation of instrumentation shall be performed by fully qualified and competent tradepersons, skilled in the particular field of work in which they are engaged, together with a suitably qualified and responsible engineer or supervisor experienced in the installation and testing of hazardous area equipment. Where applicable, the contractor shall engage the services of a specialist subcontractor to ensure the equipment is correctly installed and commissioned with guarantees maintained. All trades personnel that install tubing and compression fittings shall have completed a manufacturer's training course in the correct procedure for the installation of that manufacturer's tube compression fittings. Technical requirements. All instruments and their associated components shall be installed in accordance with all relevant drawings and data sheets. All instruments shall have individual connections to the process unless otherwise specified. No instrument shall be installed so that it depends for support upon the impulse lines unless so designed. The electrical connection. All instrumentation shall be accessible, i.e., from grade, permanent platform access walkway, or mobile platform. Where the contractor considers that the location or the method of installation of any instrument requires clarification, he shall consult with the company for a directive, and whose approval must be obtained prior to starting work on the installation. Instrumentation and equipment shall not be mounted on or from process pipework, vessels, or handrails unless specifically stated in the project drawings, or where prior approval is obtained from the company. Instruments shall be located in accordance with the company-approved layout drawings and hookups, and shall not obstruct access or walkways. They shall be located so that they are protected from damage by passing or falling objects, and clear of drainage points of condensate, water, and process fluids from adjacent plant equipment, i.e., flow transmitter indicators shall be local to the associated flow valve. Indicating instruments used for a direct check on control actions taken in the plant shall be located within readable distance from the controlling device bearing the closest relationship to the instrument. Dial thermometers, pressure gauges, thermowells, etc. that are line-mounted shall be plainly visible and accessible from grade or permanent walkway or access platforms. All instruments shall be installed as shown on approved hookup drawings, which are tabulated in the instrument installation schedules. Where practical, instruments shall be mounted on 2-inch NB pipe stands at 1.3 meters to CL of instrument above grade or platform. CL equals center line. All brackets and supports shall be protected against corrosion, e.g. by adequate priming and painting. Care shall be taken to ensure that any forces developed by the expansion of piping or vessels will not affect the instrument installation. A permanent label engraved with the instrument details shall be fixed at the location of each instrument. This label shall not be fixed to the instrument and can be either stainless steel. The contractor shall ensure that the nameplates or metal tags installed on all instruments by the vendors are intact at the completion of the installation work and are correct in accordance with instrument data sheets. Where an instrument or control valve, etc. is lagged, nameplates shall be attached by use of U-bolts and brackets, and not fitted to the lagging. Materials of the nameplates shall be stainless steel. All instruments shall be provided with the following identification means: stainless steel label provided by instrument manufacturer containing instrument details. Traffolite tag number to be mounted on the instrument stand. Black letters on white background shall be used for the control instruments and valves. White letters on red background shall be used for safety-related devices. Contractor to ensure all tapping points are in the correct orientation to keep the impulse lines as short as possible, at the same time enabling control instruments to be mounted as close as possible to their associated control valves. Mounting materials containing asbestos and asbestos in non-composite form shall not be used. Mounting materials shall be selected to avoid electrolytic corrosion. All pressure instruments fitted with blowout vents shall be mounted with a clearance equal to at least one blowout vent diameter between the vent and nearest obstructing surface. Modifications to prefabricated panels must not be made without the company's approval. Items such as miniature control valves, solenoid valves, etc., for mounting behind panels, and whose position is not previously specified, shall be rack-mounted on an approved framework. Fasteners and clips for fixing tubing and cables to their background materials shall be stainless steel. The use of nylon quick fasteners shall be avoided for clipping cables, tubes. All electronic instruments which may operate in gas-hazardous atmospheres shall be installed in accordance with specified requirements for preventing ignition of flammable vapors. All plant-mounted instruments shall be weatherproof after installation. Where necessary, the instruments shall be provided with protective shades. Displacer-type level instruments shall be protected with custom-made sunshade. The shade shall be fixed to the mounting plate in such a way that quick installation and removal is guaranteed. Sunshade material shall be sun and UV resistant. The dimensions of the sunshade shall be approved by the company. When necessary to prevent corrosive or solids-bearing fluids from entering instruments or instrument lines, seals or purges shall be provided. Where diaphragm-type seals are most applicable, they shall be given first consideration. Diaphragm seals shall normally be integral with the instrument. When a diaphragm seal is required, the largest practical size should be applied. Special attention shall be paid to diaphragm seals on low differential pressure and pressure applications. The application of diaphragm seals with capillary extensions shall be kept to an absolute minimum. The capillary tubing material shall be AISI 316 type stainless steel and be shielded by flexible stainless steel tubing with a neoprene according to manufacturer's standard. The length of the capillary tubing shall suit the application, but the length should be at least 1.0 meter. For differential pressure applications, the capillary tubing shall be of the same length. The maximum allowable operating temperature for liquid-filled diaphragms shall be observed. Applications of diaphragm seals with capillary extensions require the written approval of the company. Insulation shall be provided for impulse lines wherever required. The insulation should normally consist of mineral wool, wrapped around and covered with a weatherproof material. The chloride content in the mineral wool insulation shall not exceed 10 milligrams per kilograms. Technical requirements. Flow instruments. Differential pressure instruments for flow measurement should be located within a distance of 1 meter from the measuring element. Where this is not possible, e.g., due to limited accessibility of the connections, the instrument may be located away from the element, provided that the longer impulse lines will not cause measurement errors due to false static heads. Except where 4 tappings are required for segregation, each flow measuring element shall be provided with 2 tappings. All small diameter orifice meter runs, and those large diameter orifice meter runs having orifice flanges with corner tappings shall always be located in horizontal pipes. Other flow measuring elements, especially those having 4 tappings, should be located in vertical pipes. Where this is impossible, e.g. because of requirements for straight length or accessibility, the measuring elements may be located in horizontal pipes. In order to avoid an extremely long upstream straight length, control valves should be located downstream of the measuring element wherever possible. Where isolating valves are located upstream of the measuring element, they should be of the straight-through type, such as gate valves or ball valves, and be fully open under normal plant operation. For accurate flow measurement, a minimum length of straight and unobstructed pipe shall be provided both upstream and downstream of the measuring element. When not supplied in prefabricated form, orifice meter runs shall be fabricated at the construction site. Special attention shall be paid to those cases requiring 2 tappings in each orifice flange. After checking the correct execution and position of the tappings, the meter runs shall be welded or bolted into the main piping, provided that the total straight length required is not disturbed by protruding gaskets or excessive welding beads on the inside of the pipe. Flow meters used for leak detection system shall follow vendor-supplier guidelines for installation. Technical requirements. Level instruments. Level instrument connections are made directly to vessels and not to process flow lines or nozzles, unless fluid velocity in the line is less than 0.6 meters per second. Connections and interconnecting piping should be installed in such a manner that no traps or pockets can occur. Drain valves should be provided at the lowest points. Level devices should be placed away from areas of turbulence and should not interfere with other vessel parts or instruments, such as thermowells or sample nozzles. Some level instruments are susceptible to damage due to vibration. To minimize effects of vibration, they should be installed on a rigid support. If this arrangement is employed, tubing and conduit connections should be installed to allow for movement. Where turbulence caused by emptying and filling rates or by mechanical agitation can affect the sensor, it is necessary to enclose the element in a stilling well. A stilling well should be used in all cases for displacement or float-type elements, except for rotary-type floats. A stilling well may be required to protect a bubble tube against excessive turbulence. Stilling wells and bubble tubes shall be firmly supported. Sufficient headroom should be provided to permit withdrawal. Displacement and float-type level instruments shall be placed as close as possible to the vessel to improve response. If any external chamber instrument or a standpipe cannot be located close to the vessel, the size of the connecting pipe should be enlarged to facilitate the transfer of liquid on level changes, thereby reducing the loss of response caused by the long sensing and equalizing lines. Differential pressure type level instruments shall be located below the process connections on the vessel. All diaphragm DP type level transmitters shall have isolation valves to isolate the sensor, diaphragm, from process side, and shall have drain provision near the tapping point for carrying out the instrument zero and calibration checks. Sensing lines of differential pressure type level instruments shall be checked to make sure that they are connected to the proper sides, HP and LP, of the instrument. On vented vessels, since it is not necessary to compensate for the vessel static pressure, a gauge pressure transmitter may be used if accuracy and measurement span are satisfactory. If this criterion cannot be met, a differential pressure type level instrument is used. If an external chamber instrument or a differential pressure type level instrument is used to measure level in a vented vessel, one of its input connections, as appropriate, may be open to atmosphere instead of being connected to the vessel. An external chamber instrument thus installed may require additional bracing. Vented connections shall be fitted with bug screens. For a pressurized vessel, when using a 3-valve manifold for differential pressure type level instruments, there is a potential for the sealing fluid from the upper leg to flow into the lower leg, or the process fluid from the lower leg to flow into the dry upper leg when the equalizing valve is opened inadvertently. In general, the use of the 2-valve manifold for level instruments consisting of 2 block valves with no equalizing passage is recommended, and a 3-valve manifold should be used only when it is specified by the project company. All level instruments shall have connections to the vessel or a standpipe. Connections to process piping are not permitted. The connections shall be located such that impingement from process streams flowing into the vessel is prevented. Where necessary, this shall be achieved by installing deflection plates in the vessel. Internal level instruments shall be mounted to a suitable flange provided on the top or side of the vessel. Internal level instruments shall not be applied for applications where removing the instrument requires a shutdown of the process. Chambers for displacer level instruments shall have connections at the side of the vessel, in such a position that normally the midpoint of the displacer coincides with the normal operating level. Each pair of connections shall be perfectly in line and exactly vertically above each other, thus ensuring a vertical position of the displacer chamber without exerting stress thereon. Displacer level instruments shall be installed initially without the displacer, unless it can be ensured locally that the displacer will not collapse at the equipment test pressure. The displacer head shall be installed on the displacer chamber in such a position that the instrument case is easily accessible. Where purge pipes are used for differential pressure level instruments, the contractor shall check that they are internally pointing upwards or downwards as required by the application. The installation should also be checked for proper drain and vent facilities, and where applicable, flare connections and insulation. For level monitors and level switches, a flanged connection shall be provided below the bottom drain valve on the float chamber, or for high pressure, a double block and bleed arrangement shall be installed in the drain system to assist field calibration and checking of the float mechanism. Technical requirements. Pressure instruments, pressure gauges or switches are normally line-mounted. Where vibration is anticipated, instruments should be installed on independent supports. Instruments using mercury switches shall be mounted on supports attached to a rigid foundation, e.g. concrete floor, main column, etc. For pressure gauges or switches, the use of a gauge valve is usually recommended. A typical method of installation uses an isolation valve, T, and drain or vent valve. Pulsation dampeners, when required, shall be installed on the instrument process connection or downstream of the instrument valve as close to the instrument as possible. For pressure transmitters, the use of a 2-way manifold or instrument valve is usually recommended. The method of installation using isolation valve, T, and drain or vent valve is also acceptable. Pressure gauges on pump suction and discharge lines shall be easily visible from the relevant pump starter switch, as well as from the suction and discharge valves. The gauges should preferably be installed close to the discharge valves. Pressure gauges with diaphragm seals shall be installed as close as possible to the process connection. Instruments for measuring the differential pressure across vessels will always be located away from one or both connections. Connections for pressure instruments shall normally terminate in Haparent's lapped joint flange, unless other sizes are dictated by the size of the measuring device. Connections on horizontal pipes shall not be located in the bottom part. Technical requirements. Temperature instruments. Wherever possible, thermowells shall be located downstream of orifice assemblies so as not to disturb the flow pattern in the line upstream of the orifice plate, or interfere with the requirements for unobstructed straight length. In vertical lines above rotating equipment, thermowells shall be located such that in the case of failure of the thermowell, it will not fall into the rotating equipment. Where surface mounting is used, thermal insulation shall be applied at least 1 meters upstream and downstream of the measuring element, applied also when the equipment is not insulated for other reasons. Only when it is completely impossible to use a straight well should curved wells be considered. The radius of curvature shall then be at least 1.5 meters, and the total angular displacement shall not exceed 45 degrees. The location of the nozzles on the vessels shall be calculated to rationalize the number of multiple element types required. All unused thermowells shall be kept closed, e.g. with a 1/2 inch NPT threaded plug. Capillary tubing for temperature instruments shall not be pierced, stretched, or twisted. Bends shall have a minimum radius of 0.1 meters. Any excess length shall be neatly coiled and clipped together in coils not less than 0.2 meters in diameter. Technical requirements. Control valves. Control valves with butt welding ends shall be installed without internals at the construction stage. A temporary spool piece shall be installed for all other control valves. Control valves with butt welding ends will normally be supplied with the internals and the actuator separately packed, and with a blind bonnet for temporary closure of the body. Where this is not the case, the internals and the actuator shall be removed on site, and a temporary blind bonnet shall be fabricated locally. The trims shall only be installed after pressure testing and flushing. During the installation of the spool pieces, it shall be ensured that the connecting flanges in the piping are in line and have the correct spacing so that the valve can be installed later without undue stress on the body. The above is especially important where flangeless bodies will be clamped between pipe flanges. For all control valves, it shall be ensured that after the construction work has been finished, the valve can be disassembled in situ and/or removed completely. Access to the control valves shall not be obstructed by adjacent piping or plant structures, etc. Ancillary equipment, e.g. booster, quick exhaust, solenoid valve, etc., shall be installed as close as possible to the control valve and be in accordance with hookup drawings. All tubing connections shall be stainless steel. Tubing shall be imperial size. It shall be fire retardant and resistant to UV degradation. Accessories such as valve positioners, lubricators, or hand wheels, if applied, shall be on the side adjacent to access from platforms, etc. The hand wheel is always the first priority to control the operation. Control valves shall normally be provided with block valves and a bypass valve. However, a bypass shall not be provided for control valves for safety shutoff or depressurizing service, and on some applications where solids suspended in the stream may collect and block the bypass valve. The block valves on either side of the control valve shall be of the straight-through type and of the same size as the piping. The bypass valve shall have a nominal capacity factor at least equal to, but not more than twice, the capacity factor of the control valve. The bypass valve shall have a good throttling characteristic. For critical applications, the bypass valve shall have the same body and trim construction as the control valve, but with hand wheel operation only. Provisions shall be made for draining and/or depressurizing the control valve manifold. At least one drain valve shall be provided adjacent to the control valve, preferably downstream of the same, depending on the physical layout, But shutoff valves shall always have a drain valve on the downstream side for leak testing the valve. For hazardous, corrosive, or toxic fluids, more extensive provisions may be required. Startup strainers shall be provided upstream of control valves with a labyrinth-type low-noise trim. Technical requirements, installation procedures in the control center. Instrument installation work in the control room, computer room, as in the auxiliary room, shall not start before these spaces have been completely finished by civil engineering, and, where required by the climate, the heating air conditioning system is in operation. The instrument power supply, including the backup system, shall also be available. Prefabricated consoles and system cabinets. Before prefabricated consoles and system cabinets are installed, a free space of sufficient size shall be allocated for unloading and unpacking. The access into the control room shall be free, i.e. not blocked by temporary or permanent structures. As much as possible before being uncrated, crates shall only be lifted at the indicated points. The slinging of crates using a running eye shall never be allowed, and spreaders shall be used where necessary to prevent the possibility of crushing the crate. After removal of the packing, the consoles and system cabinets shall be moved immediately into the control room. The packing material shall be transported to a safe location for eventual disposal. The consoles and system cabinets shall be handled very carefully to avoid undue stresses to the metalwork or damage to the surface finish and the instruments, etc. The handling of consoles and cabinets may be facilitated by using trolleys or skids specifically designed for the job. Technical requirements, instrument piping. Instrument piping and tubing. Instrument piping and tubing to be installed can be classified in the following categories: air supply piping, transmission signal tubing, instrument impulse piping. Instrument piping and tubing shall be routed so that they are kept as short as possible, consistent with good practice and accessibility. Do not obstruct traffic through the plant. Do not interfere with the accessibility or removal of equipment, e.g., pumps, motors, exchanger bundles, valves, etc. Avoid hot environments and potential fire risk areas. Will not be subject to mechanical abuse, e.g., being stepped on. Avoid areas where spillage is liable to occur, e.g., from overflowing tanks. Are clear of drainage points of condensate, water, and process fluids from adjacent plant equipment. Avoid areas where escaping vapors or corrosive gases could present a hazard. Avoid process piping and are provided with sufficient clearance from piping which may require lagging. Pipes or tubes installed but not connected shall have the ends closed in an approved fashion to prevent the entry of foreign material. For a period of up to 1 week, adhesive tape may be used. For a longer period, caps or plugs shall be used. All tube bending, cutting, coupling with and end terminations shall be carried out in accordance with the recommendations of the manufacturer and according to good installation practice. Where tubing is installed in a horizontal run, ensure that the fall of the tubing is in the correct way and at the recommended degree of incline. Tubing installed onto galvanized tray shall be supported along its whole length with proprietary molded PCP or similar material blocks of the correct size and fixed to the tray with compatible material nuts, bolts, and washers. The spacing between blocks shall be 1.0 meters maximum. Threads for screwed fittings are specified by the company. Contractor must ensure that the specified thread and thread sealants are used. The number of joints in pipework shall be kept to a minimum consistent with good practice. Where modifications are made to existing pipework or tubing systems involving threaded joints, it is essential that traces of previously applied sealant are removed from threads before the connections are remade. Instrument air supply headers. Instrument air supply headers piping shall be galvanized. Subheaders to users, including secondary and tertiary loops, branching off the main header shall be connected to the top side of the pipe. Each takeoff is provided with an isolation valve. Spare takeoff from the headers will have a valve, the free end of which shall be plugged by means of a nipple and screwed cap. Subheaders shall be installed so that they are self-draining with adequate draining facilities. On small headers, this will normally be achieved via instrument air filter regulators, but on larger headers, blowdown valves are to be provided at low points. Where the size of the instrument air supply piping is not specified, its size should be chosen from the table below. Up to 5 users, 1/2 inch NB pipe. Up to 12 users, 3/4 inch NB pipe. Up to 25 users, 1 inch NB pipe. At individual instrument takeoff points, isolation valves should be provided. Each valve shall be identified by the instrument tag number. Instrument tubing between the valve takeoff and final user shall generally be 1/2 inch ODSS tube, unless either the project drawings or final user size dictate otherwise. Each header or subheader shall have 10% spare valved and capped takeoffs provided, with a minimum of 2. No hose connection shall be made on the instrument air supply header or subheaders, nor shall any header or subheader be connected to the production process or other system. All instrument air supplies shall be filtered and regulated. When the filter regulator is not part of the vendor-supplied instrument or equipment, it shall be supplied and fitted by the contractor. Air sets shall be mounted in such a way as to be readily accessible for inspection and cleaning. The contractor shall be responsible for leak testing the air supply installations from the isolation valve on the air header to each and every one of the air users so connected. Water shall not be used at any time as a test medium. Where there is no other indication of the loading pressure on a pneumatic operator, a 50mm 316 SS loading gauge shall be installed. Technical requirements. Transmission signal tubing. Tube fittings shall be compatible with or of the same material as the tube to which they are connected. Only fittings correct for the installation shall be used. PTFE tape shall not be used as a thread sealant on instrument airlines, including air transmission and controller output signals. Where required, a proprietary brand of sealing compound shall be used, and shall be applied sparingly so that there is no intrusion of the compound into the airlines. All pneumatic signal tubing shall be cleaned by blowing through with filtered air before connection to instruments. Sufficient slack shall be provided in all air tubing to avoid strain on the instrument connections and to facilitate dismantling of the instruments. All control valves and direct vessel or compressor-mounted transmitters shall have an extra loop in their air tubing for maximum flexibility. The loop shall be in the vertical plane and above the horizontal line of the tube to ensure no condensate buildup in the tubing. Instrument impulse lines. All impulse piping shall be self-draining and in general be run with an incline to ensure adequate fallback to the process connection. The slope of the impulse pipework shall be down from the tapping point for liquids and up from the tapping point for gas service unless special provisions are made for venting and draining. Impulse lines shall be kept as short as possible, consistent with good practice and accessibility. Vents and drain lines shall be connected as per the piping installation design. Instrument impulse tubing material shall be 316L SS as a minimum. Tube fittings used shall be 316L SS as a minimum and of the double compression ferrule type, swage lock or equal. All venting instrument and pilot valves shall have bug screens fitted to the atmospheric vents. Should carbon steel pipe and/or fittings be used, they shall all be primed and painted. Where there is a danger of mechanical damage to pipes, abrasion caused by sharp edges and rough surfaces, protective measures shall be taken, e.g., by corrosive-resistant protective bushings. Lead-throughs shall be made watertight by means of a sealing compound or by the use of bush couplings. Where welding on instrument process lines is required or specified, it shall only be performed by welders qualified to ASME 1X and inspected by approved NDE specialists to the same standard as the associated process pipes, including X-ray requirements. Instrument connections. All instruments shall have their own individual tapping, except where shown on approved drawings. Combining of instrument tappings, such as a pressure transmitter connected to the HP connection of an orifice plate, shall not be allowed. Locally mounted pressure gauges shall be installed in accordance with the relevant hookup drawing. Instrument supports. Close-coupled instruments should be supported from the associated process piping and occasionally from adjacent structural members. The use of line-mounted supports should be considered, but requires the approval of the company. Instruments shall not be line-mounted when temperature or vibration from hydraulics or operating equipment will affect the operation of the instrument or cause damage to instrument piping. The manifold block, which forms part of the impulse line arrangement, shall be bolted to a mounting plate. Mounting of the manifold shall be by means of a 50 mm pipe clamped to the instrument stand. Transmitters shall be supported by the manifold. Selection of the type of mounting plate depends upon the various components required. L-shape, when a sunshade is required. When a junction box is required, in combination with a requirement for a protective housing for transmitter. Rectangular, all others. Instrument piping shall be supported from pipe supports and any other permanent structure. Instrument piping supports shall not be welded to stress-relieved equipment or internally lined equipment. Instrument piping supports shall be sufficient to maintain the instrument piping in a neat manner. Piping and tubing support. Piping or tubing and their supports shall be kept free from vibrating structures or equipment. Process piping or handrails must not be used to support instrument lines unless the drawings indicate that this is the preferred method or where prior approval is obtained from the company. Piping and tubing runs shall be adequately supported and fixed at distances not exceeding those in the following table. Tubing, 3/8 OD, 0.75 meters, 1/2 inch OD, 1.5 meters, 1/4 inch OD, 0.5 meters. Capillaries of filled systems shall be run independently of all other lines and shall be continuously supported using mild steel angle with clips at 0.5 meter intervals. Where pipes are led through apertures made in the body of the tray, the edges of these apertures shall be lined with lead or plastic. Where steel support is considered sufficient, the parts shall be properly primed and painted. The run of pipe and tube supports shall be determined with proper reference to the general layout of the installation to be served. Where the runs penetrate through the walls or floors, separating areas of different hazardous area classifications, the penetration shall be made using a proprietary transit frame and blocks to ensure and maintain the safety of the different areas. No unnecessary junctions shall be made in the tubing. This is in keeping with the specifications and good engineering practice. All supports shall have 25% free space. All cable trays shall have 25% free space. Weather protection. All instrument installations shall be designed so that the operation of each instrument shall be unaffected by the environmental conditions. Technical requirements. Instrument cabling. General. All cabling for instrumentation shall be installed in accordance with the project drawings and the instrument manufacturer's recommendations. Instrument cables shall be segregated from power cables to prevent electrical interference. Shielded cables shall have their shields grounded at one end only unless otherwise specified. Cable types. Instrumentation cables shall be of the type and construction specified in the project documentation. The following general types are typically used: single-pair or multi-pair cables for signal transmission, triad cables for analog signals, multi-core cables for multi-conductor requirements, special cables for specific instruments as specified by the instrument manufacturer. Cable routing. Cable routing shall be planned to minimize interference and ensure accessibility. Cables shall be routed away from sources of heat, vibration, and potential mechanical damage. Cable trays and conduits shall be used for cable protection and support. Cable tray and conduit installation. Cable trays and conduits shall be installed in accordance with the project drawings. Trays shall be properly supported and fixed at intervals not exceeding those recommended by the manufacturer. Conduits shall be sealed at both ends to prevent the ingress of moisture and contaminants. Cable identification. All cables shall be clearly identified with permanent markers at both ends. Markers shall be durable and resistant to environmental conditions. Identification shall correspond to the project drawings and cable schedules. Cable termination. Cable terminations shall be made using appropriate connectors and methods specified by the instrument manufacturer. Terminations shall be neat, and connections shall be secure to prevent loose connections and potential signal loss. Cable testing. All cables shall be tested for continuity, insulation resistance, and signal integrity before being connected to the instruments. Test results shall be documented and submitted for approval. Grounding and shielding. Instrument cables with shields shall have their shields grounded at one end only, unless otherwise specified. Grounding shall be done in accordance with the project documentation and best practices to minimize electrical interference. Cable bending and support. Cable bending shall be done in accordance with the manufacturer's recommendations to prevent damage to the cables. Supports shall be installed at regular intervals to prevent sagging and mechanical stress on the cables. Spare cables. Spare cables shall be provided as specified in the project documentation. They shall be properly coiled and labeled, and their ends shall be sealed to prevent the ingress of moisture and contaminants. Documentation. Complete documentation of the cabling installation shall be maintained, including routing plans, cable schedules, test results, and any deviations from the project drawings. Documentation shall be submitted for approval and kept as part of the project records. Hazardous areas. In hazardous areas, cables and their installation shall comply with the applicable standards and regulations. Special attention shall be given to ensuring the integrity of seals and the protection of cables from potential hazards. Fire protection. Where required, fire-resistant cables shall be used. Cable installations shall include fire stops and barriers to prevent the spread of fire along cable routes. Inspection and approval. The completed cable installation shall be inspected and approved by the relevant authorities before commissioning. Any defects or non-conformances shall be rectified before the system is put into operation. Technical requirements. Cable termination instrument cables shall be terminated in accordance with the project specifications and manufacturer recommendations. The following procedures and requirements shall be followed. General requirements. All cable ends shall be stripped carefully to avoid damage to the conductors. The length of the stripped section shall be as per the terminal manufacturer's specifications. Cable shields shall be terminated as specified, typically grounded at one end only to avoid ground loops and interference. Termination of conductors shall be made using crimped lugs or other approved connectors. The type of connector shall be suitable for the cable type and the terminal block. All connections shall be secure and mechanically robust to prevent loosening due to vibration or other mechanical stresses. Terminal blocks. Terminal blocks shall be of the type specified in the project documentation, suitable for the number of connections and current rating of the circuit. Terminal blocks shall be installed in enclosures that provide adequate protection from environmental conditions, such as dust and moisture. Terminals shall be clearly and permanently labeled to correspond with the project drawings and cable schedules. Instrument and junction box termination. Cables shall be terminated in instrument and junction boxes as per the project drawings. Entry points shall be sealed to prevent the ingress of moisture and contaminants. Where specified, junction boxes shall be equipped with terminal strips to facilitate the connection of field instruments. Cable glands used for cable entry into junction boxes shall be of a type suitable for the cable and the environmental conditions. Testing and verification. After termination, each connection shall be tested for continuity and insulation resistance to ensure integrity and proper installation. Any connection found to be defective or not meeting the specified standards shall be re-terminated and retested. Test results shall be documented and submitted for approval. Documentation. Detailed records of all cable terminations shall be maintained, including cable identification, termination locations, and test results. Documentation shall be kept up to date and submitted as part of the project handover package. Quality control. Terminations shall be inspected by qualified personnel to ensure compliance with project specifications and standards. Regular audits shall be conducted to verify that terminations are performed correctly and consistently throughout the project. By following these guidelines, the integrity and reliability of instrument cable terminations will be ensured, contributing to the overall performance and safety of the instrumentation system. Technical requirements. Loop testing, general requirements. Loop testing shall be performed to verify the correct installation and functionality of all instrument loops. This includes checking the continuity and integrity of wiring, as well as the correct operation of instruments and control systems. All instruments and control devices in the loop shall be properly calibrated before testing. Testing procedures. Each instrument loop shall be checked for proper wiring and termination. This includes verifying that the wiring matches the project drawings and that all connections are secure. Signal continuity shall be tested from the field device to the control system. This includes checking for any open circuits, shorts, or incorrect wiring. Instrument power supplies shall be checked to ensure they are providing the correct voltage and current as specified. The output of each instrument shall be simulated, and the corresponding response at the control system shall be verified. This includes checking that the signal is received correctly and that any alarms or indicators function as expected. For control loops, the correct operation of control valves and other final control elements shall be verified. This includes checking that the control signals correctly modulate the control elements as intended. All safety interlocks and shutdown functions shall be tested to ensure they operate correctly in response to the appropriate signals. Documentation. Detailed records of all loop tests shall be maintained. This includes documenting the test procedures, results, and any issues identified during testing. Any deviations from the expected results shall be investigated and resolved. The resolution of any issues shall be documented. Test records shall be submitted for approval and kept as part of the project documentation. Quality assurance. Loop tests shall be performed by qualified personnel with experience in instrumentation and control systems. Testing equipment shall be calibrated and maintained to ensure accurate and reliable results. Regular audits shall be conducted to ensure that loop testing is performed consistently and in accordance with the project specifications and standards. Completion and handover. Upon successful completion of loop testing, a comprehensive report shall be prepared summarizing the results of all tests. The completed loop test documentation shall be reviewed and approved by the relevant authorities before the system is handed over for commissioning. Any outstanding issues identified during loop testing shall be resolved to the satisfaction of the company before final acceptance. Quality assurance, inspection, and testing. Quality assurance. A comprehensive quality assurance program shall be implemented to ensure that all instrumentation and control system installations meet the project specifications, standards, and regulatory requirements. The contractor shall develop and submit a quality assurance (QA) plan for approval. This plan shall outline the procedures and practices to be followed to maintain the highest standards of quality throughout the project. The QA plan shall include procedures for the inspection and testing of materials, components, and systems to ensure compliance with the project requirements. All work shall be performed by qualified personnel with the appropriate skills and experience for their assigned tasks. Training and certification records for personnel shall be maintained and made available for review. Inspection. Regular inspections shall be conducted throughout the installation process to verify compliance with the project drawings, specifications, and standards. Inspections shall cover all aspects of the installation, including but not limited to material and equipment receipt and storage, installation of instruments, cabling, and supports, termination and connection of cables, tubing and piping installations, calibration and testing of instruments. Inspection checklists shall be used to document the results of each inspection. Any nonconformances or deviations from the project requirements shall be recorded and addressed promptly. Final inspections shall be conducted upon completion of the installation work to verify that all systems are installed correctly and are ready for commissioning. Testing. A comprehensive testing program shall be implemented to verify the functionality and performance of all instrumentation and control systems. The testing program shall include loop testing to verify the correct operation of individual instrument loops, functional testing of control systems and safety interlocks, calibration of instruments to ensure accurate measurement and control, performance testing to verify that systems operate as intended under all expected operating conditions. Detailed test procedures shall be developed and submitted for approval. These procedures shall outline the steps to be followed for each type of test, the acceptance criteria, and the methods for recording test results. Test equipment used for calibration and testing shall be calibrated and maintained to ensure accurate and reliable results. Calibration certificates for test equipment shall be maintained and made available for review. Documentation. All inspection and test results shall be documented and compiled into comprehensive inspection and test records. Inspection and test records shall include details of the procedures followed, the results obtained, any non-conformances identified, and the corrective actions taken. The completed inspection and test records shall be reviewed and approved by the relevant authorities before the system is handed over for commissioning. A final quality assurance report shall be prepared summarizing the results of all inspections and tests. This report shall be submitted as part of the project handover documentation. Completion and handover. Upon successful completion of all inspections and tests, the installation shall be reviewed and approved by the relevant authorities. Any outstanding issues identified during inspections or tests shall be resolved to the satisfaction of the company before final acceptance. The completed system, along with all relevant documentation, shall be handed over for commissioning and operation. The quality assurance program shall ensure that the installed instrumentation and control systems meet the highest standards of quality and reliability, contributing to the overall success of the project.